Welcome to St. Joseph's College for Women Autonomous, Vishakhapatnam. Welcome to St. Joseph's open web-based learning platform, So We Learn, for a soulful and enriching e-learning experience. Welcome to the Department of Mathematics. Our topic is Analytical Skills. Instructor for this chapter, Mrs. V. Bharati, MSc B.Ed, pursuing PhD, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Vishakhapatnam. Good morning everyone. Today we are going to discuss compound interest. In aptitude and competitive exams, compound interest is one of the most important topic in the arithmetic section. In simple interest, we earn interest only on the original amount. But in compound interest, the interest earned is added back to the principal. So next year, we earn interest on a bigger amount. That is why it is called interest on interest. And white people's helps money grow much faster. This is what banks and investments use in real life. Let us see the learning objectives. In this chapter, the students will be able to learn, define simple interest and compound interest, memorize the formula of simple interest and compound interest, derive the formula of compound interest, applying the concept of simple interest, calculate compound interest when the interest is compounded annually, half yearly, and quarterly. Know the concepts of growth and depression. Derive the formula of growth and depression applying the concept of amount in different situations. Let us see the contents. Contents of this chapter is introduction, types of interest, definition of compound interest, derivation of compound interest, types of cases, related examples, and practice problems. Before going to see the general definition of compound interest, see the introduction part. Before people began using money, purchase and sales of goods used to be performed through direct exchange of goods, as there was no uniformity of various goods under this system. The values of all goods were converted in terms of money, thus ensuring that a proper value is paid for the goods purchased. Meaning of this: earlier, goods were exchanged directly through barter system, which lacked uniform value. Later, money was introduced to give a standard value to goods and ensure proper payment. Continuation part of the introduction. When we need money, we normally go to banks, post office, insurance, corporations, and other financial companies which lend money and accept deposits. Sometimes we borrow money, either paying simple interest or compound interest. When money is borrowed on simple interest, then the interest is calculated uniformly on the original principal throughout the loan period. In case of compound interest, both the borrower and the lender agree to fix a certain unit of time, say 1 year or half year or 1/4 of a year, to settle the account. In this slide, continuation part of introduction. When money is borrowed on compound interest, the interest accrued during the first unit of time is added to the original principal, and the amount so obtained at the end of the first unit of time is taken as the principal for the second unit of time. The amount of this principal at the end of the second unit of time becomes the principal for the third unit of time, and so on. After a certain specified period, the difference between the amount and the money borrowed is called the compound interest. Let us see types of interest. There are two types of interest: simple interest and compound interest. In the last class, we already discussed what is simple interest, and also we have seen some related examples and problems. Now we are going to see what is compound interest and the derivation part and the related examples in this PPT. Let us see what is compound interest. Compound interest is the interest calculated on the initial principal, which also includes all of the accumulated interest from previous periods on a deposit or loan. Thought to have originated in 17th century in Italy, compound interest can be thought of as interest on interest and will make a sum grow at a faster rate than simple interest, which is calculated only on the principal amount. Let us see the derivation of compound interest. Let us consider principal amount BP, time is equals to n years, and rate is equals to r. In order to calculate compound interest, first we need to calculate simple interest for the first year. So take simple interest. In suffix we put 1, no? So here 1 indicates simple interest for first year. As we know, the formula for simple interest is PRT by 100. So after got simple interest, we need to calculate amount for first year. So amount formula is equals to principal plus simple interest, which is equals to, since we don't know principal amount, no, just keep P as it is, plus simple interest for 1 year. From this line we got simple interest for 1 year formula is PRT by 100, which is equals to, if you are take P as common from this equation, after taking P as common, the left over part is 1 plus R by 100, and let us consider this whole part as P2. Next, simple interest for second year. So here simple interest for second year, we just put 2 here. Simple interest, in the suffix we put 2, which is equals to, again from the same formula, PRT by 100. But whereas here, instead of P, we just put P2. Amount after the second year. Amount formula is P2 plus simple interest 2. Means 2 means second year, which is equals to. So we got principal amount for the first year is P2 plus simple interest for second year formula, just substitute here P2 into RT by 100, and again take P2 as common, 1 plus R by 100, which is equals to, if you go back and look into the P2 value, P into 1 plus R by 100, just substitute here instead of P2. So P into 1 plus R by 100 into, we already have 1 plus R by 100 here, no? Just write down as it is, which is equals to P into, here 1 plus R by 100 repeated 2 times, no? So whole square. Similarly, if we proceed, after n years, we can deduce A is equals to P into 1 plus R by 100 whole power n. So we need to calculate compound interest. So this is the formula, amount minus principal, which is equals to P into 1 plus R by 100 whole power n minus 1. In the previous slide, we have already seen that how to deduce the compound interest formula. So here the compound interest formula is amount is equals to P into 1 plus R by 100 whole power n, where A is nothing but total amount after n years, P is the principal or original value, R is the rate of interest per annum, and n is equals to number of years the money is invested. Let us see, compound interest can be calculated in three different ways. In general, compound interest can be calculated based on how frequently interest is added to the principal. The three common methods are annually, half yearly, and quarterly compounding. Next, we will see interest compounded half yearly. In this case, the interest is not added once a year but twice a year. That means every 6 months. So, if the annual rate is R percentage per annum, then for half yearly compounding, we take R by 2 percentage for every half year. And if the time given is n years, then the number of compounding periods becomes 2n half years because there are 2 half years in 1 year. The formula for amount becomes A is equals to P into 1 plus R by 2 divided by 100 whole to the power 2n, which is also written as P into 1 plus R by 200 whole power 2n, where P is equals to principal, R is equals to annual rate, and N is equals to time in years, and A is equals to amount. Now let us see interest compounded quarterly. Here, interest is added 4 times in a year, that means every 3 months. So if the annual rate is R percentage per annum, then for quarterly compounding we take R by 4 percentage for every quarter. And if the time given is n years, then the number of compounding periods becomes 4n quarters because there are 4 quarters in 1 year. The formula for amount is equals to P into 1 plus R by 4 whole divided by 100 to the power 4 by n, which is equals to P into 1 plus R by 400 whole power 4n, where P is equals to principal, R is equals to annual rate, N is equals to time in years, and A is equals to amount. So in quarterly, compounding rate is divided by 4 and the time is multiplied by 4. Next, we will see how compound interest formula is used in population problems. This is case 1. Here the condition is if the population growth is constant for all the given number of years, that means every year the population increase at the same rate R percentage. So to find the population after n years, we use the same compound interest formula, which is equals to P into 1 plus R by 100 whole power n, where P is equals to present population, R is equals to rate of growth per year in percent, and N is equals to number of years. Now let us see case 2. In this case, the population growth rate is not constant. It varies every year. For example, let's say the growth rate is A percentage in the first year and B percentage in the second year. Then to find the population after 2 years, we can't use one formula directly. We have to apply the growth year by year. So the formula becomes population after 2 years is equals to P into 1 plus A by 100 into 1 plus B by 100, where P is equals to initial population, A is equals to growth rate for first year, and B is equals to growth rate for second year. In the same way, if rates changes for 3 years, we will just multiply 3 terms. Now the last one is case 3. Here the situation is opposite. Instead of growth, the population is decreasing constantly. For example, due to migration or other reasons, if the population decreases by R percentage every year for n years, then to find the population after n years, we use population after n years is equals to P into 1 minus R by 100 whole power n, where P is equals to initial population, R is equals to rate of decrease per year in percent, N is equals to number of years. Notice the only difference from case 1, here we use minus sign because it decrease, not growth. Let us solve example 1 together. Here the question is, what will be the compound interest on 4,000 rupees in 2 years when rate of interest is 5% per annum? Basically, the question is asking, if you deposit 4,000 rupees in a bank and the bank gives 5% interest every year, and that interest gets added to the principal each year, then how much total interest will you get after 2 years? So that's solution. First write down given values as it is. Here the principal amount is 4,000 and rate is equals to 5% and the duration of time will be 2 years. So by using the compound interest formula, A is equals to P into 1 plus R by 100 whole power N. Here the principal is 4,000, 1 plus R by 100 whole power N, and instead of R just substitute 5%. 5% means we can write 1 plus 5 by 100 after taking LCM. So we got 105 by 100 into 105 by 100. Instead of N, we just put 2 here. So it calculate 2 times. So we have to write 2 times 105 by 100 into 105 by 100, which is equals to 4,000 into, after cancellation we got 21 by 20 into 21 by 20, and again after simplifying we got 4,410 rupees. So but the question asks us to find compound interest. Compound interest formula is amount minus principal. Just now we got amount is 4,410 rupees minus principal amount. In the question itself they given 4,000. So after subtracting these two values we got 410 rupees as a compound interest. Let us see example 2. Find the compound interest on 1,000 rupees at the rate of 8% per annum for 1.5 years when interest is compounded half yearly. Let's try to understand this question clearly. If you invest 1,000 rupees in a bank and the bank gives 8% interest per year but adds interest every 6 months instead of once a year, then how much interest will you earn after 1.5 years? Let's see the solution. First write down given details. Principal is 1,000 and rate is equals to 8% and time duration is equals to 1.5 years. But since the interest is compounded half yearly, we need to convert it into number of half years period. So which is equals to 3 by 2 into 2. After cancellation we got 3 half years. By using the formula, A is equals to P into 1 plus R by 200 whole to the power of N, which is equals to, why we are using 200 here means we are going to calculate compound interest for half yearly, so that's why we put 200 here. So just substitute values here. 1,000 into 1 plus R is 8 by 200 whole power. N indicates time period, that is 3, which is equals to 1,000 into, after solving this we got 208 divided by 200 whole cube. So after solving this we got 1124.86 as an amount, but the question asks us to find compound interest. So compound interest formula is amount minus principal, which is equals to, here the amount is 1124.86 minus, question itself they given principal amount, that is 1,000, After subtracting these two values, we got 124.86 as a compound interest. Let us solve example 3. Find the compound interest on rupees 1,60,000 for 1 year at the rate of 20% per annum if the interest is compounded quarterly. Let's understand this question step by step. If you invest 1,60,000 rupees and the bank gives 20% interest per year but adds interest every 3 months instead of once a year, then how much interest will you get after 1 year? So in order to find compound interest on this particular amount, just look into the solution. First write down given details. Here the principal is 1,60,000. Here the rate is 20%. So but whereas here we compounded quarterly, so that's why we are divided by 4. So after cancellation we got 5% as a rate of interest, and time duration is equals to 1 year. In 1 year we have 4 quarters, no? So 1 into 4, which is equals to 4 quarters. By using the formula, in order to prove compound interest we need amount. So that's why first we need to calculate amount. Amount formula is P into 1 plus R by 100 whole power n. Just substitute principal here 1,60,000, 1 plus here the rate is equals to 5 divided by 100 whole power, duration is 4. So 1,60,000 into 105 by 100 whole power 4. After simplifying these values we got 19,000, 1,94,481. So the answer is 1,94,481 is the amount. But our target to find compound interest formula is amount minus principal, which is equals to 1,94,481 minus 1,60,000. After solving or subtracting, we got 34,481 rupees as a compound interest. Now let's do example 4. Here the question is, what will rupees 1,25,000 amount to at the rate of 6% if the interest is calculated after every 4 months? Let's understand this question step by step. First, say for example, if we invest 1,25,000 and the bank gives 6% interest per year but adds interest 3 times a year once every 4 months, then how much total money will you have after 1 year? Here interest calculated after every 4 months means it is compounded 3 times per year. Look into the solution. First write down given data. Here the principal amount is 1,25,000. Rate of interest is equals to 6% per annum and the time duration is 1 year. Next, we need to adjust 4 months compounding. Since interest is added every 4 months in 1 year, we have 3 such periods because 12 months divided by 4 months will give 3 periods. Also, the yearly rate of 6% will be divided by 3. So the rate per period is equals to 6 by 3 is equals to 2%. So after we convert time and rate of interest, we need to substitute all these values in a compound interest formula. And we know amount formula in compound interest is A is equals to P into 1 plus R by 100 whole power n. Here the principal amount is 1,25,000 into 1 plus, here the rate of interest is 2 divided by 100 whole power. Here the time duration we got 3 quarters, right? So whole cube, which is equals to 1,25,000. If you take LCM, we got 102 by 100 whole cube. After solving this whole part we got 1,32,651. So the amount at last we got 1,32,651 rupees. Now let's see example 5. Here the question is, at compound interest, a sum doubles in 5 years. In how many years will it become 8 times of itself? Just understand in simple terms, if your money becomes doubles in 5 years with compound interest, then how much time will it take for the same money to become 8 times bigger? Just look into the solution. We are told the amount doubles in 5 years. So amount is equals to P into 2 after 5 years. Now we want the amount to become 8 times. We know that 8 is equals to 2 cube. This means the money must double 3 times. If one doubling takes 5 years, then 3 doubling will take 3 into 5, which is equals to 15 years. So finally, it will take 15 years to become 8 times of itself. Moving to example 6. A loan of 80,000 rupees is borrowed at 15% compound interest, compounded annually. Find the amount after 3 years and the compound interest earned. Let's understand this question clearly. If you take a loan of rupees 80,000 at 15% interest per year, and interest is added once every year, then how much total money will you have to pay back after 3 years? And how much of that is just interest? Look into the solution. We are going to solve this problem in 3 steps. In step 1, we just write given data as it is, and in step 2, using the compound amount formula, and in step 3 we are going to find compound interest. Look into the solution. First write down given data. Here the principal amount is 80,000 rupees and the rate of interest is 15% and the time duration will be 3 years compounded annually. Let's move on to the step 2. Use compound amount formula to calculate amount. So amount formula is P into 1 plus R by 100 whole power n, which is equals to 80,000 into 1 plus, instead of R we got, or we have already 15. So 15 by 100 whole cube, since the time duration is 3 years. So 80,000 into, after solving this inside part, we got 1.15 whole cube. Move on to the next line, which is equals to 80,000 into, if you multiplied 1.15 into 3 times, we got 1.520875. After multiplying this whole part, we got 1,21,670 rupees is the amount. Next, we are going to find compound interest. Since we know amount and principal amount, it is easily calculate compound interest. The compound interest formula is equals to amount minus principal. Just now we got the amount, that is 1,21,670 rupees, minus here the principal amount, question itself the given 80,000. So after solving or subtracting 80,000 from 1,21,670, we got 41,670 rupees as a compound interest. So finally we got amount is 1,21,670 rupees and compound interest is 41,670 rupees. In this slide, we are going to see one simple interest formula, one simple interest example. Let's see the question. A person borrowed 60,000 rupees at simple interest. After 4 years, he paid 84,000. Find the rate of interest. Let's understand this question. If someone takes a loan of 60,000 rupees, after 4 years, he pay back 84,000 in total, then at what yearly interest rate was the loan given? So look into the solution. We are going to solve this example in two steps. In step 1, we are going to calculate interest. Interest formula is amount minus principal. Here the amount is 84,000 minus principal amount is 60,000. After subtracting this value, we got 24,000 as a simple interest. So by using simple interest formula, we are going to calculate rate of interest. So 24,000 is equals to PTR by 100. Just substitute all these values here. So 60,000 into, since we don't know rate of interest, write down R as it is, into, here the time period is, or duration is 4 years. So into 4 divided by 100, which is equals to 24,000 is equals to 2,400 into R. After simplifying this whole part, we got 2,400 into R. And further simplification, we got R is equals to 10%. Therefore, we got the rate of interest 10% per annum. Points to remember. In case of simple interest, the interest is calculated on the initial principal, whereas compound interest is calculated on the principal and the interest on it after every conversion period. The period after which interest is added to the principal is called conversion period, and the interest so obtained after a number of conversion periods is called compound interest. If the conversion period is 1 year, the interest is said to be compounded annually. Continuation part of the previous slide. Here the amount is P into 1 plus R by 100 whole power n, and CI is the compound interest, R is the rate of interest per annum, and N is the number of conversion periods. Increase in certain quantities over a period of time is called growth. Decrease in the value of some asset over a period of time is depreciation. Let us see the practice problems. Find the simple interest on rupees 5,000 at 6% per annum for 3 years. Next one, calculate the compound interest on 8,000 at 10% per annum for 2 years. Third one, a sum of 12,000 is invested at 5% as compounded interest for 3 years. Find the amount. Fourth one, find the difference between simple interest and compound interest on 10,000 for 2 years at 8% per annum. The last question is, a population increases by 4% every year. If the present population is 25,000, find the population after 2 years. Thank you all for sparing your valuable time to listen all these videos. Thank you once again.